Okay, here we are. Welcome, everyone. Today we're going to hear about and discuss lessons learned working in Terraform with 1,000+ engineers. Pretty big title, right? That's about as big as it gets. And we're going to hear some pretty big lessons and see some great demos to back it up. We've got our guest today who's going to cover our big picture concepts, and we're going to go through some nice techniques and different things that you'll be able to walk away with and put into practice. But before we get into it and I introduce you to our other main character here, I do want to give a pointer to our community guidelines. Be professional, be friendly, be welcoming, patient. Don't be an internet troll. If this is confusing to you, check out the link that I've got under there, and it will direct you towards correct behavior. Because we do want to hear from you. If you have questions or comments or anything, please give them to us. But okay, so enough with that. I want to introduce my guest here, and by introduce, I mean I'm going to let him introduce himself. So if you will, your name, where you're at currently, what you've done.
Yep. Hi, everyone. Thank you for having me here. My name is Kien Pham. I'm currently a software engineer at codec.io, helping developer with code visibility. Prior to joining Codec, I was a staff cloud solution architect at Coinbase, the crypto exchange, to help customer buy and sell crypto exchange. And prior to that, I was a cloud solution architect at Amazon Web Services, AWS. That's a quick background about me.
Yeah. So some context with how this got started and why you, the audience members, should stick around and really get into this. I got the pleasure of meeting Kien back at reInvent this past year, and we had a big conversation about Terraform at a much bigger scale than a lot of people get to see. And his experiences are both they're very seasoned, and there's a lot of breadth and depth there. Because as he mentioned, not only is he working at a startup currently where he gets to do everything from brand new. Previously to this at Coinbase, he got to see a massive overhaul of a lot of different things on infrastructure on a really big level. And in fact, I'd like you to tell us, Kien, what were you brought on to do at Coinbase?
Yeah. So when I joined Coinbase at the end of the crypto run last year, I was tasked to help the Coinbase build out the NFT marketplace, right? So it's nft.coinbase.com now. It's live. So if you remember back then, Coinbase have a waiting list of around 1.5 million customers before we launch. So we were concerning, right? Like if we launch with that much customer waiting, can our infrastructure, can our services handle that scale? And so I was and my team was thinking about that, or how we can use tooling like Terraform and the rest of AWS infrastructure to help us scale.
Yeah.
Great challenge, yeah.
Which right there, right when I heard that, when we were discussing, okay, there's going to be a lot of lessons learned in that context that we can bring and give to the wider audience and all the Terraform users, because there's a lot of challenges that we're gonna discuss. But before we get too much in that, I want to roll back prior to that some, because before that you were at Amazon Web Services as well, where, if I recall, you were one of those golden people that got all 13 certifications or something like that, correct?
Yeah, internally we call them a golden jacket. So we literally bought a golden jacket for any of our solution architect or a team member that achieve all certs. Yeah, so it's very fun internal challenge, and I did that as part of the challenge. Over 2 years though, right? It take a while.
Yeah, of course. But of course, that's that adds to a lot of the perspective and discussion that we've had, which one of the big things for this is understanding how infrastructure and these challenges happen at this big organizational setting. So why don't we talk about that some, right? Let's talk about when you were at your previous gig. You came in and you had a lot of challenges to face in terms of tackling this problem of this NFT marketplace. And what did they look like?
Yeah. So I would say a lot of company, right? We all start with like a startup mentality, right? We start small, and Coinbase was being in business for over 10 years now, right? So when Coinbase first started, is a lot of infrastructure, even let's just say Terraform itself, right? There's a lot of features, right? Terraform wasn't available at that time. For example, Terraform module, right? One of the main things we want to talk about today, it wasn't available at that time. So a lot of engineers before me have to do is basically create toolings on top of that, right? Same thing with AWS technology, right? So a lot of tooling back then, we just have to custom build. So over time, right, any kind of like custom build toolings like that become a technical debt, right? So what that means is now we are no longer kind of relevant, right? In terms of, we couldn't support at the scale that we try to move, right? And supporting the same tooling, they are actually slowing us down, right? Versus, using the latest and greatest kind of method the tooling have to offer. So for example, talking about Coinbase, right? So we are a hyper growth company. So at any crypto run, right? That means when, so just back up, right? Crypto have a cyclical cycle, right? So there's like, so we kind of in a winter right now, right? Where the crypto market kind of cool down, but there's like crypto bull run, right? Where basically everyone's interested in buying it, right? So if you have a lot of customer, million of customer interested, it will create like this spike, right? From us. Like for us, infrastructure engineer, we want an exciting product, but we want something called a boring launch, right? So what that means is when we launch NFT marketplace, we want it to be a super boring launch event for us, right? Like no news, no outages, none of that, right? But marketing team can also have, NFT can be super exciting. So what we are doing is when I first joined, we analyze, right, what are we having, right? So we determined that if we continue with the current infrastructure that Coinbase used to have, we actually couldn't launch NFT marketplace. Why is that? Because we actually run into physical limit with AWS. So like Coinbase use a lot of AWS technology, but for example, when you work with, at this scale, right, we run into a lot of physical limitation. What does that mean, right? So let's say when you create an AWS account, you launch like 10 or 20 EC2 machine, for example, that's okay, right? And sometimes AWS actually limit you, right, due to spamming, due to verification, right? So those can be soft limit, right? What that means is AWS will be, after verification, they can actually lift those limit for you.
Yep.
But there's certain limit that AWS actually cannot lift, right? Like for example, the number of ENI, right? The number of hyperplane ENI that can talk to each other, because like increase those limit actually cause instability at the control plane, right? So when we work with when we try to launch an NFT marketplace, we look at all the network connectivity, all the services that we need to use and connect to third party provider. We saw that, right? We say we will run into these limitations very soon, right? And it actually prohibit us from actually scale and supporting at least 1.5 million customer out of the gate.
Right. So you come into Coinbase, they've got this sort of legacy, not legacy, but this infrastructure that started way back when, before Terraform supported some of the newer and bigger and brighter features that can help with this scale. I know from our conversations and what you've mentioned in passing, you all had to sort of roll your own internal system to deal with those things, but there were also the issues with the with cloud provider in general, which is you were hitting the top limits, which you don't see a lot of. Usually when you're, unless you hit a big organization or within a big organization, you see those soft limits. You're like, oh, call Amazon if you hit this quota. It's like, oh, that's not going to happen. But not only were you all having to do that, you were also getting the bad news of, okay, you can't do anymore. It doesn't matter how much you ask. And so what was the step after that, right?
Yeah. So basically, our team came up with a term internally called saying a 10x program, right? What that means is we want to 10x our current number of customers, right? In multi-million. So to support this 10x architecture, we have to think about how we think about our AWS account strategy, right? Whether do we use one account, do we use multiple account, right? And if we use multiple account, how do we divide these, VPC design? How do we do interconnected, and how do we do actual multi-regions, right? So these are very typical problem a lot of big tech company have to solve. So the way we solve it is basically make sure that our service connectivity is can talk to each other across multi VPC. So for example, one of the technology we adopted would be transit gateway, right? It become a hub and spoke model where NFT services can be on one or multiple VPC. And if it need to connect to services that send out email or send out notification, it can connect to the other account VPC via transit gateway. That's just like one tiny example. And then the way we do that is basically we codify all our infrastructure via Terraform, right? So whether if we need to create that private link or that peering or that attachment, it's all done via Terraform.
Yeah, gotcha. So out of necessity and out of best practice, you all went towards the multi-account model in terms of just the conceptual or architectural model, however you want to call it. And in doing this, what did this look like from an infrastructure as code standpoint and like the ops standpoint? What did you all have to do to make that happen?
Yeah. So from basically, so once you go into multi-account, basically you have to manage multi-environment, right? So like, the way we're thinking about, so basically we segment account basically per environment, right? So like one account can be for dev, one account can be for stage. So the way we did that is to make our design much simpler. So let's just say NFT, we have like 10 microservices, right? So we might have 3 accounts, right? One for dev, staging, and productions, for example. And all of the services running into that account. So the reason why we did that is it actually limit a lot of so it helps us with compliance, right? So like, for example, the worst case, if something wrong with the NFT launch or the service, right? It's self-contained, right, within that account. And then it's also easier for our security and infrastructure security team, right, to monitor and make sure we adhere to compliance and best practice. And second thing, it's also limit blast radius, right? What that means is if something went wrong or someone, were able to, get into those services, maybe the maximum damage they can do is to that single, product or services, right? Where we lock down the other, services dealing with payment or crypto withdrawal on another account.
Nice. So we wanted to do this first part here to just sort of set the context in terms of a couple things. One, sort of the issue that we're looking at here. You start from one point, and it's never where you expect, right? In an ideal world, everyone starts from a perfect place, but the perfect place always moves. You start with what you have, and you grow. As you grow, you're going to incur all sorts of tech debt in the form of actual day-to-day code, but also just in the architecture that you've decided upon. It's going to create a lot of decisions that you need to make. And at some point, someone like Kien's got to come in and look around and be like, we got to fix all of this. How are we going to go about doing it? And Kien got the unique perspective of being able to deal with that. And as we just talked about, one of these things he had to go about doing was it's directly related to all of the lessons that we're about to dive into. But he's got a lot of experience here, and the unique perspective was that where he is now gave him the opportunity to ask the question, what if I could do it all over again? And he's actually currently getting to answer that question at the startup he's joined post Coinbase, which is at Code C that he spoke about. And we're going to now go into those lessons. So why don't we talk about that first lesson here, which is, as you told me, keep your infrastructure as code modular. What does that mean to you, Kien?
Yeah. So to say that, I can maybe share the problem that we run into at Coinbase.
Okay. Yeah.
So what happened is when we start to launch, same story, right? Trying to launch NFT, we say we couldn't launch. What happened? What that means is we basically think of it as like we have single account, and as we try to add more services, microservices, and every of those services create a whole bunch of resource behind the scene, right? So for example, it might create like these whole bunch of S3 to store, NFT image. It will create these SQS. It create, Elastic Cache and EC2 and RDS, whatever. So we have a gigantic state file in Terraform, right?
Yay.
What that means is every time we need to add something new, it takes forever. It takes hours, right? Yes, that's really slow, right? So yeah, we all heard the joke, right? A lot of blending now is Terraform blending and applying take forever. So we were saying no, and then like I said, right, we have our all custom tooling, and we couldn't use Terraform module back then. So Terraform module is one of the ways we have to solve this issues. So what we end up doing is basically when we create these 10x architecture design, we start thinking about that, right? So now this is a brand new account, Then if we gonna create these new resources, we can maybe potentially make them modular, right? And make them self-contained into its own kind of module. So that way, when we do planning or apply, it's only applied to a certain services. So that's what we did.
Yeah. So just for everyone who perhaps like, you can use Terraform for quite a bit and never really dig into the depths of the state file. Just as a quick nutshell for that, a state file, whenever you do something in Terraform, if you're curious about how Terraform's keeping track of everything that's live, that's what it uses. It uses the state file, but whenever it updates that stuff, it's actually got to go and make the API calls outbound to whatever provider or services that you're hooked up to. And how long did you say that would take for y'all times?
Yeah, normally around 1 hour to plan. And also, right, sometimes when you plan a lot of resources, AWS actually time out, right, because of certain call limit. So we have to keep retrying, right? So it is really a painful developer experience for us internally.
Yeah. And so because of that, y'all had to move towards modules, which is not only something that y'all moved towards there, but also something that when you asked her if I could do it all over again, is something you implemented here. And you've got a demo for this, right?
Yeah, I have a demo to show you what the painful way of doing things, right? And then the modular way of doing things. Yeah.
Nice. So let's see it.
Yeah.
Just tell me when you're ready and we'll put your screen up on.
Yep. Let me share my screen right now.
Okay.
Okay. And yeah.
Ready?
Yes, I'm ready.
All right.
So right now, what I'm showing you is two accounts. For the first demo, it's actually just one account, right? So in this account, I have an S3 buckets, right, called TF module example, right? And within this bucket, I have multiple state file, right? Like Cole said, whenever you do anything in AWS with Terraform or any service provider, right, it will create these kind of JSON state file to saying that this is my current state of the world, right? So like this is how much resource that I have. It's saved in here. So I have like four different apps here, module, right? The first one is non-module, and then the other three is modular. So right away you can see that the main difference is the size, right? This one is like 3 meg, and the rest is like only 17. So when you were working with the smaller state file, it's super easy to parse and plan. So I'll go back to my demo code.
So you were, just for clarification, you were showing those to show, one, the big state file was a representation of what it's going to look like if you're keeping everything and it's non-modular. And the other three were after you've gone and you've split them up, correct?
That's correct.
Nice.
Yeah. Okay. So for example, on my main, so here I'm in the app one, right? That app one is the one that doesn't have like non-modular. So it's very simple. This is how you define it, right? This is where the S3 bucket you want to save your state file, right? This is the name of the state file, right? And then these are stuff just like my local AWS profile and regions. So what that means is when I run Terraform plan, right, it will go to that state file and do it. So let's see, I'm in that right now. So I'm going to go to app one. Let's see. I'm going to go to module example, app one. So if I do TF plan, so what's doing right now is it going through that state file, right, and saying, hey, I'm gonna compare, right, my state file versus whatever in AWS, right? And why is it taking this long? So this is what I did, right? So this is a very simple demo where I create like 1,000 or around 500 security groups, right? Think of the security group example, right, of your actual production or dev account that have a lot of resources, right? So maybe in the real world, you might have like 20 RDS, 10 DynamoDB.
Yeah.
Group. And just to
prove
the point, right? Planning still going, right? So think about this, right? Every time you need to change anything, do every single thing, right, on an account that have this much resources, you have to wait for this long. Yeah, so basically the iteration cycle is very slow.
Yeah, so in terms of, I've talked about this before. and we discussed it as well. If this takes what 10 minutes, 15 minutes, and you need to make like 10 to 15 experiments, right? There's a good hour plus of your day, yeah.
Yeah, like, and the worst case, like for example, right after planning, there's nothing changed or nothing, now you like few minutes, right, waiting for that, and nothing happened, for example, right?
Yeah. So what happens? So do you have an example in here of like changing or adding something new, just so we can see that this really does?
Sure, we can just do it. Yeah. So for example, in this case, again, right, this is my security group, right? This is what I did. I create 500 of the security group, and I've added 500 in ingress and egress group. Okay, let's say tomorrow for this app or this account, right? Someone or some team member need to add something new, right? So let's just say, yeah, I'm gonna add new like live demo. So now what I'm gonna do, I can just keep planning. I can do start applying right now because apply will do plan anyway. So basically, that's the idea, right? I have to wait for that to be done, and then after that is done, I can actually add that new single security group to this gigantic state file.
Yeah. So, and we're gonna take a look at how this gets fixed now, right? Because this is not what you obviously what you want to do, right? It works when you've got like 10 security groups or a lot less, but once you start crossing this threshold and you're seeing this, it's about time to move on,
That's right. Yeah. So like not just Terraform itself, but think about AWS account as well, right? Like you don't want to have an account that have these too much resources contained in, let's say, one certain VPC, right?
Yeah.
You might run out IP, subnet mask on depend how much you size your subnets, right? So it's very important to think about that, as you start growing, start thinking about your design and how you can move and segment your services.
Yes.
To another accounts.
Nice, and I'm glad that this has our plan here has given us enough time to talk about that.
Okay.
There we go.
You can see, right? Yeah, it's yeah. So this is exactly what we wanted to do. I want to add that new group, so yeah, I can just say yes.
Yep.
Hopefully, yeah, it should be quick now, right? Because the thing is done. So just to prove that it's working, I can just go here and search for this security group on my AWS account, and it should be here now. That's not the name. Oh, let's see. Maybe let me refresh it. So 512 should be 513 now. Yeah, I didn't refresh. Okay, it's right here now.
Yay! All right.
After a while.
So next step, you're going to show us how to split into modules, but just to set the context for the architecture, so people know what's going on. Your recommendation here is you're going to have some downstream service or infrastructure, right? That is going to look upwards to these other modules.
Yes.
With the idea that you can't get past the fact you're going to have to plan all 512 of these at some point. But what you can prevent is having to plan all of them every single time, right?
That's correct. Yeah. So like if your app or services eventually get this big, right? That's fine, right? But the idea here is if your app doesn't need to be this big, right? You don't have to fall into this. So my second demo here, let me turn this off, right? So if I go to app 2 module, everything is still the same, right? So I still go to the same backend, but I save it to its own key, right? So what that means here is like all of the stuff that I'm gonna do for this app, it have its own state file now, right? So like, let's say this app or this services only need like these 100 or 200 resources. That's all it needs to care about, right? It doesn't need to share the same state with other app and services, right? And then the security group here is I also make them modular now. So what that means is instead of define the actual security groups in here, I just call the module, right?
Yeah. And so let's take a real quick step for people that maybe haven't done these, right? Modules are where you just package up some infrastructure, so some just base resources, and you can pass into them, as we see Kien doing here, some different input variables, and it keeps them contained, and we'll go and create them for you. So if you've worked in any other programming language before, you can just think of them like making a class, right? Or if you want to abstract those out, even thinking like pulling in a different framework or a plugin or different external function to work for you.
Yeah, and for this demo purposes, I make this module super simple, right? But you can make your module as complex as your business requirement is need. For example, you can make a module that create like a tier 3 web app, for example, right? Like launching this will create like a serverless application for my end, right? Here, I'm just saying that, hey, using this module will help me create a security group, right? So what that means is I don't have to keep redefining it, right? Basically, you don't have to copy and paste code into your application. And actually, that's also one of the issue I see from a lot of team is not everyone is familiar with AWS and Terraform. So what the engineer is doing, they just copy and paste, right? So hey, it works for your app 1. I'm gonna make it copy and paste it for my app 2.
Yeah.
So it might work, right? But the problem we end up to is few things, right? It wasn't cost optimized for the certain workload, right? And then people probably just copy and paste the same infrastructure. It might way over right side, oversizing a certain workload, right? So
that is a really good point. Like if you want to know like what's the simplest, most bare bones problem that modules are going to solve for you, it's going to be the copy paste problem, right?
exactly.
You've got similar resources, copy pasting all over the place. Well, let's break them down into a module. And can you actually show us this module real quick?
Yeah, so this module is very simple, right? Here, so I create a module and then I put the name in here. It's called security group. So module usually is just very two simple thing, right? You need a main TF file and a variable to pass it in, right? Because if module is not allow a lot of passing in, then it's not as useful. Yeah. So for example, in this module, I also create a security group, right? And then 2 ingress group. But for example, for this demo purposes, I allow you to pass in a name, right? So what that means, you can like do like a custom name for your apps, right? In this case, for demo, I just hard coded VPC. But in real world, right, you probably also want to pass in a VPC. And I actually demoed it on the next second demo where I can pass in VPC for different environments.
Nice.
So you can see the powerful module here, right? Like if you have something that you want to set as a default, right? Like maybe best practice, security best practice, or your business best practice, you set them as a default in here, right? And then each app or each application can override them as needed.
Nice. So let's go see that this refactored app 2 module here.
Yes.
So this is going to be the one where you're using that module, and this should go a lot faster.
Yeah, much faster. So two things, right? Like for example, this case it doesn't have much, right? Like this one only create like 5 security group. So what I just want to show here is this app 2, even though it's on the same account, right? It doesn't share the same state as app 1. And let's say if this is the real use case for this app, it only needs to create those 5 resources. Then that's it, right? It doesn't need to create more. And then again, right? If you go back to its S3, app 2 module is only 17 KB, right? Whereas app 1 is like 1.3 max.
Yeah.
So just to show you, let's see. So app 2, if we override anything, right? So this is app 2. I can just do like, let's see, live demo here. And do apply on it. Yeah,
and of course it's done a lot faster.
Yeah, it will do a force replacement. So destroying. So as you can see, right, this is much faster than the first one, right? So if I go there and search for this, it will show up here now. If I refresh and search for this, so it's about 5 of them, right? So I did 5 of them, so it show up here now.
Perfect. Nice. So was there anything in the app 3 thing you wanted to show?
Oh, app 3 thing I just want to kind of expand the point here is as we continue having more app, more services, right? The idea here, it can get slower over time, but I think I just want to show this real quick. I think it's the same idea. So we just keep it for now. Yeah.
Okay, so just for just to sort of wrap it back all up for the viewers in terms of practical steps here. The idea is that if you do everything in one project, okay? And then you go and you try to plan and apply it. Terraform's got to go and it's got to figure out what's going on in your current state of your infrastructure every time, meaning it's got to go plan and refresh its state and look at every single thing, right? And as we've heard from Kien, that can become where you, instead of having Terraform plan coffee break, you have a Terraform plan, let's go watch a movie break, which, you know, I mean, that's not too bad of an idea, but probably not what you want. What he is suggesting here, and can we just take a moment to appreciate his water jug? That is so... Yeah, it's about as big as your old state file, right? So what he's saying here is that let's say that you have, and correct me if I'm wrong, Kien, that if you have an infrastructure that say has 512 security groups, those probably don't need to change all the time. So what you would do is you would separate them out into their own module, their own project, right? Mm-hmm. You would Terraform plan and apply those. Those would be created. And then your other projects, your downstream ones, would just reference those existing security groups, right? They would just reference them, and they could have their own state file. When you go and let's say you boot up new EC2 instances, they just need to point to that security group ID, right? They don't care about it. And that way, when you do the plan and apply on that, it's a lot quicker. Now, if someone needs to go and change those security groups, they get to do it in that security group project, and therefore, you know, the plan and the apply process and that state file is contained, and you're not having to wait for both when you want to just make changes to one. Is that correct?
Yep, you got it. Cool. Yep.
All right, great. So that what did this look like when you all with your what if I could do it all over again? When you went to CodeC, right? As you've told me, is the Google Maps for your code. What did this look like when you went to put this lesson into practice there? Yeah. Like, how were you thinking about it? What were kind of your steps, and what could people take from a practical standpoint?
Yeah, so we take all of the lesson that we learned, right, from having these huge state file and having kind of like a single account that do everything. We start thinking about multi-environment, right, automation and manage, using your self-managed solution to help us increase the productivity. So that's what we apply here at CodeC. And just to give context, right, CodeC is like super early stuff, like completely opposite with Coinbase, where we only have about 10 engineers. So a lot of stuff that we grow along, right? So eventually, when we get as big as Coinbase, hopefully our infrastructure is more stable.
Yeah. So I see that we're trying to bridge into lesson 2 here, but with respect to keeping your infrastructure as code modular, let me just ask a more specific question. When do you decide to turn something into a module in its own separate project versus leaving it in your big one?
Yeah. So I would say from what I'm seeing is reusability, right? So the moment you can see that, hey, someone else might need this, right? Or this make a lot of sense that we, for example, S3, we always create this S3 bucket. We always turn on this encryption on with this key, right? So maybe we can maybe extract that out, right? And make that as a module so a lot of team can reuse them, right? Or if you have a services that always do a certain things for all the app, for example, let's say your company is all serverless and you always have a Lambda authorizer with API gateway combo. So every app will need something like that, right? You can basically say, yeah, this is a module to front it all of my front end app, for example. Then it can become a module and you just plug them in.
Yeah. That makes sense. So as soon as you see a repeatable pattern, that's when you need to start splitting it up. And do it early. And yeah, do it in as many places as you can. Okay, so let's see here. That's going to take us on to lesson 2, which you already sort of touched on, right? Which is, let me put this up here, which is kind of when we discussed this one, it was a number of things, because we wanted to make this sort of like a toolbox of techniques that you can pull from, that while all aren't necessarily directly related, they all are important, and they've been something that you've dealt with. So just starting with multiple environments, right? Can you touch on us again what you mean by that?
Yeah, so like for any dev, right, we always think about dev staging or production, right? So that type of environment, whether you do it on one account, right? For example, from AWS, you can do one account with multiple VPC segregated by VPC, or you can do like one environment per account, right? You can do that. Or for Coinbase, we actually have multiple production environment, right? We have like environment to do load tests on, right? So it really depends on your current needs. But think about how you want to speed that environment early on. It's super helpful, right? Yeah.
So that makes sense. So the most, as soon as you say those key words, probably everyone gets the idea of the environment, right? Staging, development, production. You want these different sandboxes for people to go and either, if you're in the development, create chaos, staging, less chaos, production, complete chaos. No, I'm kidding. That one's where it should be, where it should be least, right? So in terms of multiple environments, what do you think defines the when it should become its own environment? Because obviously those are three, but as that grows, what would be like a fourth one in your example? Or at what point do those three start splitting into even like smaller subsets?
Got it. Yeah. So again, I'm thinking it's really based on your needs and your compliance, right? So each business is different. For example, like for us smaller stuff right now, we might not need like the full blow, multi environment yet, right? Or multi region even, right? But I think it does really depend, right? One you see the need there, basically. For example, the moment, let's say a lot of stuff I work with is the moment we see paying customer, for example, right? That's where we start to write tests, more thorough tests, more test purposes, right? So like kind of relate. So like when you see that need and then, okay, maybe I need observability now, right? Maybe I need alerting, or maybe I need it's all dedicated production environment now, right? So it is really, there's a certain driver, right? That drive that need.
Yes. I mean, that's a very good point. And that if you've ever done any fun time, I don't know why I'm calling it that, and microservices, there's no, for example, for splitting those up and deciding what should be its own service, is also driven by your business needs. There's not like one case that fits all. So that's a really good point.
Yeah.
So for this first one, I know that you have a demo that you want to show, and this one is more of a technique. This is how y'all are currently dealing with doing multiple environments. I will say very happily that they are gonna start using Terraform Cloud. But for those of you that are looking for an open source workflow, this is a very neat and straightforward way to do it with an S3 bucket. So do you want to go ahead and do this demo right now?
Yeah, I can start share my screen again, and
okay.
I already shared. Can you turn it on? And
yep. All right.
Okay, for this demo, let me turn off here. So I have a second folder called multi-account example, right? So the purpose of this demo I'm trying to show is now you have two dedicated AWS accounts. How can you use a single Terraform repo to manage them, right? So there's, like Cole said, there's multiple ways to do it. You can either duplicate all of your ACL code, right? Like create like literally a folder for dev and staging production. So that's one approach, or you can use Terraform workspace, right? Where you kind of switch workspace. For us, one thing we found that works well for us right now at Cozy, smaller stuff team, is we are using a config file concept, right? Using different backend. So I'll show you right now.
And real quick, just before you go in, I just want to give the people that aren't as familiar with Terraform, because you're obviously a Terraform pro. By backend, so first up, let's start state file. State file is how Terraform in your code knows the state of your infrastructure and what it's talking to. Backend is where your state's being kept. That's just the simplest way to put it. Where are we storing your state? And what Kien is going to show here is how they deal with when you have multiple states, right? When your one code base is being used for multiple different, say, environments in this case.
Yep. So in this case, right, I also have a different S3 bucket now, right? But in this case, how do I save my states, right? I plan for staging and I have plan for production. And in my demo here is two physical AWS account. So everything will change, right? The naming will change, the VPC will change. So basically we cannot define a single key file here anymore, right? Like, do you name them into a single file, right? Or do you separate them by using different prefix, right? And basically that's exactly what we use. So the way it works is we create like think of it like environment or config file, right, for dev and production. So there's a file called TF backend. It's very simple. If I open it here, right? So basically it's that, right? We're moving away from the main configuration, move to this file to pass it in, right? Saying that, hey, when we initialize for this development account backend, we're gonna use this key. So I just, since it's S3, if I prefix with the dev slash, right, it will create basically a folder, right, in S3. So it will create.
Gotcha.
So same thing for productions. Basically, I just prefix them with prod, right? So now what happened is when I plan or apply for dev, all my physical resources are written there on that exact prefix, right? So like completely segmented from production. So now I know that my resources are not being mixed between dev and production.
Gotcha. And this file is something you're going to pass in when you go to do your Terraform and inits and different commands you're about to see, right?
That's correct. Yeah, every time you switch, you have to pass it in.
Okay, yeah.
So that's one thing. The second thing is now you work on to multiple account, right? Then how do you authenticate, right? How do you blend? Because every time, like the first demo you see it, it was using a profile, right? In this, that one is using a demo dev profile. But now, since I'm dealing with both production and staging, I'm gonna save this S3 bucket into my production S3, right?
Right.
And there's a concept in AWS. There's a concept called role, right? Assume role. So what that means is on both dev and production account, you can create a role that you kind of allow each other to assume into each other, right?
Gotcha.
So what that means is on my laptop, when I'm using this role right here, which if you see it using a variable, I'll show you next. So if I'm using that role, it will basically go into that account that I'm trying to apply, which is production account right now because of my profile. It go into the production role. It will take that role and then assume it, right? So that role have enough permission to jump to my dev account.
Yeah. So real quick, for those who are not familiar with AWS, just because obviously like we speak AWS pretty fluently, right? When we saw the previous example, the way that Terraform was allowed to do anything to his account was in the background, he's got an AWS profile set up, which is a set of, in essence, an alias for some credentials that allows him to authenticate and authorize in terms of making stuff. The problem that he's presenting here is that role is for one account. What do you do when you have multiple accounts, right? How do you make it so that you have permissions to say, do it in your prod account, your dev account, your staging account? And so what he's doing here is first, right, we have this, we're dealing with a different state file. But second, what he's saying is that based on the environment that we're picking, we have in each of those accounts a new role created that gives just the amount of permissions. And so when Terraform, say, goes to interact with his dev account here, it's going to assume a role that exists in that dev account that allows it to do everything that it needs to do. Does that sound about right?
That's correct. You got it. Yep.
Nice.
So just to show you the config file for this, for example, if I go to productions, right? So within my config file for production, I would have, for example, something you want to use is an environment name, right? To know which environment you're in. So for example, sometimes you might want to use this variable to prefix a certain resources saying this is productions. So this is not required, but it's nice to have. But this is the main thing I'm talking about here, right? The assume role. So this is the actual ARN, the Amazon resource name, physical name to the production account, right? And for this demo, I also need a VPC ID, right? So all of these settings or configs are very specific to that production account, right? So for example, in real world, you might say, hey, I want to launch an EC2 with extra large, right? Where on dev, I only need like a micro instance. So that's where you can change them here. So basically on the same Terraform template, you can override them with variable. So that's what we are doing here.
Gotcha.
And
Nice.
just to show you dev, right? Same idea, right? But it will change. So this role is, you can use the same name or you can use different name, right? I'm just using the same name here. So you can create exactly another role on dev, right? And this one, you allow the production role to basically assume it.
Yeah. So let's see, just because this will make more sense once we see you actually use these files. Can we see you actually do a workflow using these?
Yeah. Yep. So let's do that now. So let me clear this out. Let's see. We're in the multi-account right now. Okay. So by default, if I do TF plan, it might complain. So what that means is now because I'm using variable and config, right? It doesn't know, hey, what environment or what variable that I need to use. So it will keep asking me for this. So I have to pass it in, right? And before I do this,
Can you do a clear real quick, just so we can?
Yeah.
There we go.
I have to do something called init first, right? Init is basically help me switch on different backend, right? Switch different account. So init will basically saying that I will need a config path to be able to know where's my state file is, right? So basically I do tf init and I pass in the backend config, and backend config is, let's say I'm doing the for dev right now, so dev tf backend, right? And since I'm already kind of changing stuff, I need to run one more command saying reconfigure.
You could do them all. You could just run this with -configure once, right?
Yeah, just one.
Yeah.
So like what happening right now is from Terraform perspective, I am authenticated. I am initialized for the dev environment right now.
Yeah. So basically what happened is you've got these various state files, right? A dev one representing the state of your development, a prod one representing the state of the production. And you, by running this command, you have just pointed Terraform to your dev backend one. And we're going to manage and care about those resources right now.
That's correct. Yes.
Great.
So same idea, right? So let's say I need to go plan right now. I also need to pass in my environment variable file, right? Because now I'm targeting my dev backend. So basically I do tf plan and that command, I mean var file, and now it's a dev tf var, right? So what it is doing is it will plan for my dev environment, and it will take my the dev config and apply it here, right?
Nice.
So let's see what I modify. Let's see. So on dev, let's see.
Yeah, I guess we didn't really look at what you have in here.
Yeah. I can just do this, right? So inside account example, I can also select code dev live demo, for example, right? Just to show you. And then I also prefix them with environment name already. So actually, let me move this out. So when I finish applying, what we expect to see on the dev account, there will be like development, right? And then this name. So let me apply them now.
But we shouldn't see that in the other accounts.
That's correct.
Yeah.
Because now I'm only targeting the dev account, right? I should not see this in production account. So yeah, while that is running, I can go to my dev account now and I search for that key. Refresh, search for that, and it's right here. So I just create like one development multi-account. Yeah. And just show you the proof that it doesn't work. So this is my production account, and I'm on different Firefox tab.
Yep.
It doesn't have it. It only like it have it production example here, right? So just to bring the point home. So now, okay, I'm ready, right? So I'm testing it. My dev is working. I'm gonna do exactly the same thing for production now, right? So I can go to product. So I'm switching the backend now from dev to production.
So this is almost, you can almost think it like this is Terraform switching tabs.
Exactly. Yeah. And then now I'm applied for productions, right? So basically I just reconfigure the backend. Now it's using the production config file. And then it will try to read the state file and yes, applying it.
And this is going to add that suffix to the end of that security group.
That's right. A prefix for environment name and a suffix for a live demo. Yeah. So
there we go.
So yeah, just to go back to the dev one, it's still there. There's no production at all, right? So that's how quickly we can switch and swap environments.
Yeah, and all in one code base, right?
That's right. Yeah. So as you can see, right, your actual TF file haven't changed, so you can reuse exactly the same thing. So this is guarantee that you have 100% infrastructure parity with dev and productions.
Yeah, nice. So with that, for just this technique here, can you go back to your main.tf file? Yeah. So you're always going in Terraform environment, right? In any environment that you want to create. Let's say you've got dev, you've got prod, you've got staging. Each of those need their own backends. And the way that Kien's suggesting you make a backend is by using different keys in your S3 bucket. And while you could do something like switch on environment variables right here, just for separation of concerns, he's got those split out into files such as dev.tf backend, prod.tf backend. But the state file itself is only one thing. After that, you're also going to have to think about the authentication and authorization that you have to give Terraform to work in those separate accounts. So the way that you do that is for each of those accounts, you need a role, so an AWS role with permissions that will enable it to dive in and do those things. And what you're going to need to do if you do this workflow is when you switch environments, you're going to have to run init. Can you show that command, the init command that you use?
Yeah.
Yep, the init command, reconfigure your backend there, pass in the reconfigure flag, and that will point you to the different environment. But once you've done that, you also need to pass in your unique Terraform variables file, which would you show a plan or apply using that variables file, Kien?
Yes, right here. So apply, yes.
Yes, and there we go. And that's what you would have to do as well. And and this is again wrapping up just sort of what Kien's point of that is. One code base, multiple environments, right? Keeping parity between all of them, which is great.
So now think of this. This is like 1 or 2 person workflow, right? Like you have a team of engineers. No one want to do this, by hand. So that's the way of doing this. Or you either, Git off this environment, right? As the steps. So what I mean, you can check into Git and let your CI run this. Or you can also use managed solution like Terraform Cloud, right? Even when I do this talk, I talk with Cole. Cole say, yeah, all of this you can move to cloud. So that's something we're very excited to move, and with no cost for us. Yeah, at this kind of usage. Yeah, so that's something team can then start to move over.
Maybe after you all make that move, because this is a wonderful open source workflow, and we will obviously open source is humongous for us, because without it, what are we, right?
Yeah.
Maybe after you do the migration to Terraform Cloud, we get you on here and talk about that, show the new pipeline you got set up. That'd be pretty neat.
Yep.
Okay, so that is the demo here for multiple environments, a really useful and nifty technique. I'm going to go ahead and pull your screen off here as well. But there were some other things that we wanted to talk about before we departed lesson 2. Just around on the top, well, there's a couple of topics. This is where we talked about it being kind of like a toolbox of different things you can pull off, right? Around specifically scaling, cost saving, and auditing, right? So cue us up here. I know you had sort of like a story and a context for why you felt like this point was important.
Yeah, so it's super important. So when I was at Coinbase, like I said, right, we have this crypto bull run, so we want to basically scale as much as possible. And then also due to compliance, when we create resources, we couldn't destroy them by default. So like you saw in my demo, I just like destroyed the security on the fly like that, right? A lot of company, we couldn't do that. So a lot of company would basically have another process to clean them up. So just working with AWS, some of the pain we run into is 2 things, right? First is cost problem, right? Like you create resources and you don't delete them, you incur cost over time, right? That's one problem. Or sometimes our delete script might miss something. Second thing would be the time delay between cleaning them up, because some of resource on AWS is globally unique. So for example, S3 bucket, you cannot have the same S3 bucket name with anyone else, right? Using AWS, not just your internal name. So things like that. So that means when we don't delete resources, another team, if they need to use something similar, they couldn't launch it, right?
Yep.
So those are kind of 2 problems that we had by not allowing destroy. So basically, almost like the entire last year, a lot of, with the market went down, a lot of companies focusing on cost optimizations. And we're also focusing on that as well. So we started to thinking about how can we kind of make it safer and also trying to do cost optimization at the same time. So we started leveraging, AWS resources, AWS team. So we work with AWS team to basically come up with our cost optimization strategy. So for example, one thing we started doing would be started migrating Intel-based instance into ARM, ARM Graviton-based. So Graviton is AWS technology, right? That run on ARM. So for example, any instance that kind of ending with letter G, right? C6, C7G, or M6G, those are Graviton-based instance. And the promise there is if we switch to that, we probably save up to 40% price, performance, cost, price differences.
Mm-hmm.
So we started doing that, and the good thing about these is for any managed services, for example, RDS, Aurora,
Mm-hmm.
even Lambda, right, Elastic Cache, OpenSearch. So those type of managed service, we can actually just swap instance, and
Yeah.
AWS guarantee that it will work with ARM. So we don't have to rebuild our software for that, right? Because we don't run anything on that. It's just data
Yeah.
most of the time. So, but for the EC2 itself, right, if we want to swap from C6 to C7G, for example, now we have to make sure whatever the software, let's say we use Golang or Node.js or Python, we have to make sure when we compile all the third-party dependency package have a static build library that can run on ARM64 architecture, right? So that can take a while.
Mm-hmm.
Yeah. So like how does it have to do with Terraform and how does it help us? So I would say Terraform is like after we get all of these right sizing optimization in place, Terraform is basically help us automate this process, right? It's super simple to basically have that one single line of code change, right?
Mm-hmm.
To swap instance. Once we know like how much we need to swap or how much we need to change.
Yeah.
Yeah.
So one line as opposed to remembering, a ton of different UI workflows in which you have no tracking which they happen. So that's like a very nice, simple, quick win cost optimization and resource utilization idea, which is for those unfamiliar, when he says Intel versus ARM, these are just CPU architectures, right? ARM is it's not new, it's been around for a while, but it's really taken off with the introduction of, say, the M1 Max, like the M1 and the M2 Max. Those are the type of processor or the architecture that they have. And Amazon's flavor of that inside of AWS are their Graviton instances. And you can identify those instances if I recall correctly, as you said here, they have that G on the end, right?
Yeah.
Of the instance name. Yeah. And switching to those for any of their managed services is very simple because they are managed and you get a bunch of savings in performance and resource utilization. Whereas an issue you will have to watch out for is if when you're managing your own instances, you need to make sure that whatever software you're running on them is ARM compatible before you make that switch.
Yeah, and then two more techniques I want to share that really help us, right? For example, I talk about the bull run, right? Auto scaling. So if we have a huge spike right now, how can we scale? So a lot of company I work with, usually the top three spending would be S3 for storage, EC2 for compute, and some type of database, or either DynamoDB or RDS or Aurora. So that's kind of the pattern I'm seeing. So at Coinbase, we also use a lot of compute, right? So what that means is when we have a huge spike, we need to basically auto scale our EC2 fleet much faster. So something we implement would be the ASG auto scaling group warm pool. So what that means is like on normally we need like 50 instant running. You can actually launch another 50 instant, right? Kind of pre-warm them, put them into a warm pool, and after you launch, AWS will turn them off right away, right? So that means you don't actually pay them for those 50 instant. You only pay for like EBS storage, which is very minimal. So what that means is when you actually need those 50 instant launch quickly, it already boot up, it already load your AMI, it's already have your services deployed on it. So it just turn it on, right? So it's really a quick way to basically have a quick ASG up and running. EC2 to scale to your needs. The second thing would be we also took advantage of the saving plan and reserve instant within AWS, right? So it's a concept within AWS where saving plan is more of like a time hourly based commitment, right? So let's say you run your database like 20 hour, 300 hour per month, for example, right? Then you say in the next year, you also want to run that at least minimum or more. You can actually just purchase the saving plan and you don't have to worry about what instant family that you want to switch over later, right? You just pay for that and you get discount. Where reserve instant is more like tied into a specific instance. So for example, tomorrow your team can actually run on a whole bunch of R's and C7G Graviton already. You can basically reserve whole bunch of those C7G, right? And you get a discount on that, right? But let's say next year, if Amazon come out with C8 or C9, you might not be able to migrate right away with the RI. You have to wait until your commitment is over. So yeah, so saving plan give you more flexibility, but I give you more discount.
Mm-hmm. So that was sort of an AWS aside, but which is very helpful. But there's two things there. One's a scaling issues. If you need to dynamically react, take advantage of warm pools, which is where instead of everything coming up when you need it, it's already there and ready to go, so that it can just sort of come up. And the second thing is obviously there are reserved instances where you can say, give me these instances, but you have to declare what they are. But there's also the saving plan method, which is give me this time, and you can just pick the instances when said time comes. Yeah. So the last thing we had here was around managed solutions. And, it actually kind of plays into some of a couple of questions that we've got into here. And this is around drift detection, right? So we have, so we have a question here just around curious how to apply CI/CD strategy in the same folder as we do for drift detection between environment. I obviously have an answer for this in context of managed solutions, but I wanted to know if you all currently have anything to deal with that.
Let's see. So how do you apply CI/CD in the same folder as how we do detect drift between environment? So this is regarding the demo, right? So in the demo, we have the same. Yeah. So in the demo, right, we would have the same Terraform, right, ACL, but we target different environment. So let's say we change, we have it. Okay. So I would say, yeah, if the whole workflow put in thing on a CI/CD, I think within CLI there's a flag where you do plan, and I think you can also do output, and you can check the diff on that output, right? So there's a different way, or like Cole said, we can also use Terraform Cloud, right? So like a lot of these are being sold by Terraform Cloud that we might not need to build it out, right? Like the demo I have is super simple, maybe one single person using it, and we didn't even talk about distributed logging, right? Like what if 2 person trying to apply and plan at the same time? So the issue like that is being solved by exactly the managed solution like Terraform Cloud.
Yeah, and like that was something, because ultimately when we talked about the entirety of this talk, your theme you wanted to talk about was speed, developer experience, getting things through. And you're using tons of managed solutions everywhere in the sense that you're using AWS already, right?
Yep.
And when you all decided to pick, like, say, RDS Aurora, I believe is what you're all using for the database, there's a reason for that. It's because you don't want to manage all of your own databases. And similarly, you probably don't want to set up your own distributed lock system for state files. So yeah, around that, to answer your question, the question that we have up here around drift detection, there are some different ways that you can go about it. But Terraform Cloud, I don't know why people don't know this. It is free for up to 5 users, among other things. And drift detection is one of the things that you can get on one of the higher levels, and it'll just check and see if there's any between your live environment and not tell you about them, and then you can go and either choose to have it rectify them, or you can do it manually. It also is going to deal with the distributed lock system right out the gate, and it's also going to help with all of the multi environments and stuff. And one of the funny parts of our initial meeting when I met Kien was we were walking through some of the workflows, and I was like, you can just do that in Terraform Cloud. and he hopped on and started playing. I was like, oh wow, that you can. Okay. And our original plan was actually to have that in this part of the live stream, but obviously adding a different service or whatever, and he's got other work he's got to do. But hopefully in the future, yeah.
Yeah, very excited for the Sentinel stuff that you showed me, Cole. Yeah.
Oh yeah, that's right. Sentinel policy as code, right? What if some new dev that Kien brings in and is like, I'm going to add tags with the name of just like random TV characters all over. Well, Kien can write a policy that watches for that and says, no, you cannot do that. So yeah, let's see if we can make that happen. But what else did you have in context of managed solutions and just ideas on that? Because you wanted to talk, you brought that up without me even plugging for something like Terraform Cloud. Like what were your thoughts on that?
So I would say, like, if it's not the core of your business strategy, right? Like, don't try to build it. That's what the common theme that I see here, right? So even when I had AWS, a lot of customers say, oh, I will build this and build that, right? And then next thing is AWS have a managed solution for that. It's like, it just, for example, right? Like DynamoDB, right? It's super simple to use,
Yeah, for sure.
S3, yeah, things like that.
Yeah. Why reinvent the wheel? I mean, unless you like building wheels. I mean, some of us do, right? And it can be fun. You learn a lot. But yeah, but if you're trying to get speed, if you're trying to get to market, if you're running it like a business, then this all helps.
Yep.
Which, let's see, we had some other questions around here around testing. So around testing tool for Terraform modules. We had some comments that sort of plugged some different ideas and thoughts around it, but we are running a little tight for time here. So we are going to go ahead and move on. Feel free to message myself, or I guess y'all can message Kien too. Just blow up his inbox just with, and what he'll do, he can flex, because can you just pull your water jug on here? We're talking, and he goes to take a drink of water. I was like, what?
Just try to be more efficient here, right? Like,
yeah.
stuck here for the whole day.
Yeah. So that brings us on to lesson 3 here. And this sort of wraps, everything kind of folds back up into this. And this is return on investment in DevOps and infrastructure as code. Because if you've tried to bring some sort of change to your organization or your team in terms of using new tooling, right, or using a managed solution, you're going to have to show this somehow. So go ahead and give me your thoughts on this lesson, Kien.
Yeah. So the trend I'm seeing is even from maybe from smaller startup to bigger company, right? Like by default, a lot of developers want to automate things by default. And I think by default, a lot of them get pushed back by management, right? Saying, hey, why do we need automation now, right? Why do we need Terraform, things like that, infrastructure as code, which is true sometimes, right? So the main thing I want to share here is make sure whatever you're trying to do, any related platform and automation is show the value that you can bring to the business, right?
Mm-hmm.
What that means is introduce this automation. Does it solve engineering time, right? Does it increase their productivity? Does it increase the velocity that you ship your software? So it's not just because I want to introduce this so it can be cool, right? Like,
Are you sure?
yeah, I mean, like we saw the example, right? We did it wrong. It actually slowed us down, right? With Terraform. But I think with any business, as you start growing, you will see that pain though, right? So for example, let's just say setting that 50 group or 530 group on one account, you click it at who knows 1,000 times, right? We call it click ops. And then the moment you need to move to another account, now you have to do exactly the same thing again, right? And it's create so much toil. And then I think once you're more familiar with these toolings, it actually faster to debug within them, right? So yeah, someone asked about drip detection. So that might be one source of issue, right? And let's say even right now for us, we need to debug things in production. We keep getting these 502 error from AOB. Then if we need to change something quickly, right? Now we have Terraform. We can just change one single line of code, deploy it, right? Where we don't have to go. And if something doesn't work, we can just revert it, right? So everything is like Git based, similar to how you check in your code, right? So that way it really keep track of how you plan your debug and deploy cycle. And then I would say in terms of a lot of these is like conversation with leadership, right? And the trend I'm seeing is like it's all paying off over time, right? Again, back to if you can tie this to your KPI, right? So the key performance metric. So for example, at Coinbase, we were thinking about how can we increase our developer productivity. Basically, we can measure the moment they commit code to the all the way they get the code to production, because like if code doesn't go to production, right, it doesn't provide value. So let's say if that time is 1 week versus 2 weeks, right, you can see that hey, maybe if we invest into, let's just say the root cause of that is a CI tool is being slow, or some part of the automation process breakdown, right? If we can increase a certain percentage, multiply 1,000 engineers, right, we can actually have a much faster software release, right?
That's a good, I like that. I like the taking, because when you say it for one engineer, it doesn't hit as hard as when you're like, okay, extrapolate it over
multiply
everything.
that, multiply by the years that they're gonna work, right? So back to demo one, right? If every engineer have to wait for that long, maybe spend time refactor that into module, for example, right? And you can say that, hey, if we fix that, right, one engineer per day multiplied by so those type of stuff that really help with leadership, right, to basically prove out your idea and get this thing done. And Second thing, I think I saw already, right? So when I joined Code C, we didn't even have like a staging environment. Like as a staff, right? We just have like dev and production, right? Push code. But as we have, more paying customer, and we want to make sure we feel much safer, right? When we changing infrastructure, we need like a staging environment where we want to test our thing, right? So that's where I can see the progressions, right? Like as business needs came, it make a lot of sense to start investing into these DevOps related toolings. So it's a process.
Yeah, and I think that it's important when you take that approach. You do need to think about it from a measurable standpoint. How can you show it? And if it's all in code, if you're leveraging stuff like Git, at least this is something I try to tell people. Like if you've been in anything software development, people are like, well, what's the point of infrastructure as code, right? It's like, just think about all the great, just out of the box benefits you get in terms of software and context of version control systems like Git, right? How much just in terms of auditing you get, how much in terms of logging you get, all the different things that you get from that. You get to bring all those benefits directly and instantly to your infrastructure. And from a proving to management, you can just, or leadership or other team members, if they already have the mental model of that in their head, it's a direct analogy, right? It's like, here, this is exactly, it's not even an analogy, it's a one-to-one. Yeah, but okay. And I think one of the other things you talked about was how it sort of opened up different learning opportunities for you as well, right? In terms of investing into infrastructure as code. What did you mean by that?
Yeah. So yeah, for example, when at Coinbase, when we basically trying to only apply Terraform to AWS, when we started to think about module, sometimes we actually don't have to solve the current issue, right? It's actually easier to solve a greenfield workload. So what that means is, what is the easiest workload that we can use, right, to test module on, right? So same thing with software development. Hey, serverless or AI, this is a cool new thing. Which workload can I try it on, right? So same idea. So if, for example, we start thinking about the DNS, right? For example, we use Cloudflare. So if we want to start module and start codify them, Cloudflare make a lot of sense. So we start moving toward that directions with module, and then slowly we will be able to migrate the current AWS Terraform.
Yeah, I think it's kind of interesting because this is just from my own personal take in terms of learning, say something like Cloudflare. Obviously, it has its own entire the way that the Cloudflare structured its product and how you interface with it. But there's also the underlying concepts. To me, one of the things I've liked about staying in infrastructure as code, staying in Terraform, is I get one unified way to talk to all of these different services, to all these different providers. And so I'm not having to rethink, say, learning their own language and then cross-referencing it with another's languages, right? You get that multi-provider perspective.
Agreed.
And so what would you say to people that want to, like, what are some, we talked about this yesterday, but what are some practical steps people can take? Let's say they're in an environment where they are currently all doing ClickOps, or maybe, they want to get started in this direction. Yeah. What are some practical steps they can take to start putting into practice what you put here? Say, like, moving towards infrastructure as code.
Yeah, I think there's multiple approach, right? It's really depend on your need, like how fast or how soon you want to move. So what approach I see team is doing is, you can actually take whatever you have. There's tooling that basically scan your physical resources and try to convert them into infrastructure as code, right? Or you can also start thing with the basics, right? Like us at Coinbase, we basically create new account, right? And then this new account is the new way of doing things, and we start migrating workload over, right? So that can be another approach. So, there's always a trade-off, right? Migration takes time, or same thing with greenfield, right? You want to create, so you have some new product coming up, or certain microservices that, it's much less risk, right? Safer to maybe start refactoring into this way of doing things, right? That might be another approach.
Yeah. Go ahead.
Yeah, go ahead. Yeah.
No, you go ahead.
Yeah, so I would say, yeah, it really, again, right, depend on your current state of things, and how bad it is, right? Right? If it's completely or it's halfway there, right? And then also think about the future plan as well, right? So a lot of, like, same thing with any decision, right? It's all about engineering decision. Like, are you thinking about multi-region? Are you thinking multi-cloud, right? All of that decision factor in. It will help you pick the right toolings and how to do it as well.
Yeah, yeah. So I really like the suggestion of what is it? Taking a greenfield, doing a proof of concept in some new initiative. I think that's a very, very great way to both prove the value, and you'll have all the measurements, well, measurements, metrics, same thing to show that it's working. Real quick here, I did want to address a couple questions that we have. So one we have here around just a case where you might have a Git branch, right? That, well, I'll just put the question up here. It's quite a bit, but here's what I'll say, and this goes back to our managed solutions conversations. When it comes to solving workflows like this, I'll just be honest with you. There are a lot of different ways you can go about doing this. Everyone's got their own, for lack of better word, Rube Goldberg machine in which they may have solved this issue. But I will say, Kai, if I'm pronouncing your name correctly, really seriously, give Terraform Cloud a checkout. It will solve all of this. It lets you target those specifics, switch in different variables, and you can make that stuff happen in there. It's also free for up to 5 users. So like literally there's no risk to it at all. That's going to give you a defined pattern that we've laid out, that we've seen from a ton of different customers. So it's not us just guessing, like the workflow's there. And to address another thing around an issue around that infrastructure as code in maturity in terms of compliance, we have a ton of compliance features built in, everything from drift detection to policy as code to anything else. Because if you consider any version control system to help with compliance, which they all do, again, that all gets baked right in. So yes. So could you give us a quick summary of all your lessons here? Why don't we just start with the first lesson, keeping your infrastructure code as module. What's your little elevator pitch on that lesson, Ian?
Yeah, so I would say keep your infrastructure as code and modular. Basically, from Terraform perspective, keep your state files small, right? And keep your app self-contained to very specific things. This way, it will actually speed up your plan and apply in the long run.
Nice. And then the second one here.
Yeah. So kind of following that, right? Use multiple environments, automations, and manage solution to actually increase your dev productivity. So what that means is eventually you want to run your workload into multi-environment or multi-accounts, all right? And that will help you with compliant purposes, and it's also help you speed up your development process, help you increase your release cycles. Automation would be your infrastructure as code, right? Start automating things that you can do right now. So like multiple environment, you would need automations for sure. Managed solution would help you. Someone already built it, right? Like Terraform Cloud, AWS managed service to help you move faster, so you don't have to build the infrastructure from scratch.
Yep. And then lastly.
And then after we do all of that, right, it's huge return on investment for DevOps, infrastructure as code for your business, right? So one thing I want to make sure we stress out here is, like, don't chase for the next coolest thing, right? Always work with your business and make sure you are solving the business problems. And once you kind of clearly have that use case, it's much easier to convince leadership to invest more timing, tooling into infrastructure and DevOps.
Nice. And then just one more thing, right, before we get towards the end here, and that is what is your most important takeaway? People that are just dropping in, maybe they don't know anything about anything else we've talked about. What is the biggest thing you want people to take away?
Yeah, I would say DevOps, it's a journey, right? So what that means is you don't need to get it perfect from day one. So what that means is like right now I'm working on a startup, right? So we take a baby step slowly. So eventually you get there, right? 1,000+ engineer company. And if you do it right and then always follow, like, provider best practice, it actually help you have a stable run in the long term instead of trying to rush everything in at once. and make sure you always have your business support on why you need to do certain things.
That is sound. I like it. And right, great. Okay, so can you do me something real quick? Can you hand me just throw me in our little chat that we have here the link to your GitHub repo. Though I'm going to put this up under the descriptions of everything. Some people are asking it. I just want to go ahead and post it in the chat for folks.
Okay, I'll send it to you right now.
Thank you.
Yep, I just shared with you.
Perfect. Let me grab that. So I'm going to put this in the chat for everyone as we close out here. If you have any last questions, one is just what about renaming the C and IAC to configuration rather than code? I mean, technically it is code though, right? So we're just trying to stay general here. Yeah. Let's see. Okay, I think we're clear. So just as I put the demo repos in there, those are all in the chat for you. This will all be live on YouTube after the fact. And hopefully we can get Kien back on here after we see the next journey. And perhaps we can see some Terraform Cloud. We can see some more on compliance and governance and a bigger team workflow. What do you say to that, Kien?
Yeah, sounds good. Thank you for the opportunity, Cole. Yeah.
Yeah.
Right,
he said it. He said it. So now we got to do it, right?
Yeah.
What I will say is go check out CodeC, codec.io. I'll put that right here in the chat. It's the elevator pitch that I've been given is that it is it's Google Maps for code, which is a pretty neat idea. Mm-hmm. Also, if you're looking to learn Terraform in depth, obviously we've seen some much bigger lessons. But if you want to get started with it, make sure you go to our developer.hashicorp.com platform. And if you really get to learning it, right, go check out our certifications. We have certifications for Terraform, Console, and Vault that'll obviously help you along your way. Any other thoughts, Kien?
Yeah, just want to pitch in real quick. Yeah, like you said, Code C, right, is our current my current staff right now. I'm working there. Basically, when you send in any PR pull request, right, we'll basically show you what file that you are touching, right? So basically, what file, like a visual map, right, on refactoring. And once you deploy it to production, we actually show you the flow, right? Like, for example, when someone go to your website, where do they go, right? Maybe 10% go to a certain service and 10% go to a certain flow. So super, easy way to see and debug your application live.
Nice. Yes, definitely check it out. Definitely check out CodeC. And I don't see any other current questions. Just lots of good feedback. So thank you, Kien, for hopping on here with us and discussing all your wonderful lessons. And thanks to everyone who joined us. I do want to reinforce the point that yes, as he said in his nice takeaway, we're all at different stages in our skills, levels, careers, and infrastructure. But what he talked about here, what Kien talked about, it's relevant to all stages, either what you should look out for, what you should start building now, or what you should start reconsidering from an improvement standpoint. And hopefully we'll get to see the next point in his journey at some point. And again, if you missed any of this, it will be all up on the official HashiCorp YouTube page, so you can review it at your own convenience. So thank you very much, everyone. Thank you, Kien, and until next time.
Thank you, Cole. Thank you, everyone.